Hello and welcome to the Bullion Tracker project. This is the third video in our four-part series. In this video, we'll look at how to visually represent our gold and silver prices by creating a line chart. We'll also learn how to export the line chart as an image file. To recap, in our first video, we created a Python class to get the prices for each metal. And in the second video, we looked at how to use SQLAlchemy to save the price to a database. And in this video, we're going to use the Plotly library to generate the line chart and then save the line chart as an image file. So let's get started. The first thing I'm going to do is I'm going to open up my Chrome session and search for Plotly. And we'll go to the Plotly Python open source page. And then I'm going to click the Getting Started link. If I scroll down a bit, it tells me that to install Plotly, all I need to do is pip install Plotly. So let me open up my command prompt. And I'm going to navigate over to the project folder. So it's going to be in my documents, then Bullion tracker environment. I'll activate my environment and go into the project. And here I want to just do a quick git status. And I'm on the develop branch, so I'm going to create a new branch called graph. And now we can install Plotly. So I'm going to do pip install Plotly. And once it's installed, we're going to update the requirements.txt file and commit that to our branch. So I'm going to do pip freeze, redirect that to requirements.txt. And then I can do a git diff to look at what changed. So we installed, we added Plotly and some of the dependencies of that library. So let's add that to our branch. So we'll stage this file. Okay, so the next thing is I'm going to look at the documentation to find out how to create an initial chart. So let's go to the documentation and look at the overview. And it says here that we can jump right into the examples for basic charts. And within the basic charts, we can look at the line charts. And so let's create a line chart. There are a bunch of options here, and I'm going to pick the option that I think is closest to what we want, which is this. So let's try to duplicate this. I'm going to open up my editor, create a new file, and first thing we need to do is we need to import Plotly. And I'm not going to use numpy because we'll define our own x and y lists. And let's just copy this over. And we'll save this as our graph.py file. Now, let's define x as a series of months. So January, February, March, April. And then y can be our random prices. So let's just put 12.10, 13.45, maybe 11.20, and then 9.25, let's say. And let's update this. So x equals x and y equals y. Save. And now let's try to run this. So I'm just going to do python graph.py. And as you can see, we now have this really basic chart. We have our x-axis, which is the month series, so January, February, March, April. And then on the y, we have our prices, and each data point is represented here. So January is 12.1, February is 13.45, March is 11.2, and April is 9.25. Now these correspond directly to the x and y lists that we defined. And now that we have this, we can try to improve this a bit more. The first thing I want to change is I want the line graph to display the text by default. So if we look at the chart, you can see that there really isn't any text here. So if we were to export this as an image file, it would be really difficult to understand what these data points represent. Now we can get the data if we hover the mouse over the data point, but otherwise it doesn't really show up. So if we hover, it shows up, but if we don't, it's basically just a line chart with points. Now, this is what I want to fix. I want the graph to show us the data points by default. So let's look at how to do that, and we'll look at the documentation. So the documentation says that the different options for go.scatter are documented in the reference page. So let's open that up. And let's look for the option that allows us to control the text by default. So here we have mode. So if we supply mode, we can provide in any combination of lines, markers, and text. And if we include text, then the text element appears at the coordinates. Otherwise, the text elements appear on hover. So this is what we want. But we also need to provide the text. So let's make this change first. So let's add a mode with lines, markers, and text. I'm going to copy this. And if I go back to the code, we can now provide an argument to go.scatter. And we want to provide an argument of mode. And let's provide lines plus markers plus text. Now if we rerun this, we don't see anything extra, which is identical to the previous chart. So let's go back to the documentation. So it says mode, lines plus markers plus text. And the default is lines plus markers, otherwise lines. All right, so just to make sure this is working, I'm gonna supply none and see what happens. None, save, and rerun. All right, so we know that that mode is working. So what I was testing was, is this argument a valid argument, and does it have any effect on the chart that's generated? So we know that it is in fact a valid argument. So if I supply none, there's nothing on the chart. And if I supply lines and rerun it, we get only the lines. We don't really get the little markers. And then let me close out the other tabs. If I do lines plus, what was it, marker? Go back to the documentation. Lines plus markers. Yeah, so if I do lines plus markers and rerun this, we get the lines plus these little marker dots. So if we go back, compare it to the previous chart, there aren't any dots. And then if we do lines plus markers, we get these dots at each data point. But now if I supply plus text and then run this, we get the same graph as previous. So this is exactly the same graph. There isn't any additional text. Now this is because we need to supply another argument called text, I believe. Yeah, text. So this is either a string or an array of strings. Sets the text elements associated with each XY pair. All right, so let's set this. So going back to the code, we'll say text equals and our x text, and we'll define that. So x text equals, we'll say, for now, let's just say x. And if I run this again, all right, so now we get January, February, March, April. But we wanted to actually print out something a bit more useful. So we want the date as well as the number, the price, and then we'll format that a bit too. So going back, let's update xtext. So I'm going to create a list of strings, And I want each item in this list to be a string representation of the combination of X and Y. So it's going to be the month and then the price. So let's create a loop. So I'm going to say for index and month in enumerate X, we're going to create a string, and the string is going to be the month and the value, the dollar amount. So this is going to be the Y list, and I'm going to index it using index. Okay, and then we're going to append this value to X text. Okay, and then that's being passed in to the text argument. So let's save this and run it. I'm going to do python graph.py, enter. All right, now if you look at the previous graph, we only had the Jan, Feb, March, April strings, but the update that we just did resulted in Jan dash the dollar amount and February dash the dollar amount and so on. But as you can see, this is kind of this is a bit difficult to read because it's interfering with the actual line. So I want to position the text a bit differently. So let's look at the documentation. And right here, we have an argument called text position. And what it does is it sets the positions of the text elements with respect to the XY coordinates. And the values that we can pass in are top left, top center, top right. So let's try top center. Okay, and this is called text position. So I'm going to go back to the code and we'll provide text position equals top center. Let's save and run again. And that looks a whole lot better. If we compare it to the previous one, where it's right in the center, which is the default, it's the center, I believe. So we changed it from center to top center, and the difference looks much better here, much more readable. All right. So now that we have this, the next thing I want to do is I want to represent a second graph, a second line for our silver. So I'm going to go back and let's create a second line. Now to do this, we need to look at the documentation again to find out how do we add multiple lines. So it says here that to create multiple lines, we can use the add trace method and essentially pass in the same parameters that we did before. So let's modify our code to do exactly that. So I'm going to do figure is go.figure, and then we'll just do figure.add trace, and then the rest is pretty much the same. Go.scatter xy mode name. Okay, so we don't need data. All right, so let me just run this real quick just to make sure I didn't break anything. Okay, so that looks good. Now going back, I realized that we don't really have any, if we look at the chart here, we don't have a legend, but I think that's because by default it doesn't show you the legend if there's only one item. So let's add a second item. So we're going to add a second trace. This one's going to be for silver, and the X is going to be the same. For Y, we'll need a new value. So I'm going to say Y gold and update this. This is going to be Y gold, and then we'll create a new thing for silver, new list for silver. So Y silver. We'll give it some slightly different numbers. So 2.10, 3.45, 1.2, and let's say 2.25. All right, so gold and silver, for we have different Y values for gold and silver. And let's update this. So it's Y silver. And let's go ahead and run it again. Y is not defined, line number 9. So line number 9. Okay, so we also need to create the X text for gold and silver. So we'll call this X gold text. Update these values, and then let's create something similar for Y gold text. So we're going to do the same thing for index month in enumerate X value is equal to F month, and then the dollar for Y silver index. Okay, so we need to update this also. This should be Y gold. All right, so value, okay, and then Y silver dot append value. All right, so we can simplify this later, but I just want to do a quick test here. So X gold text, sorry, this should be X silver text instead. Yeah, so X silver text, Y silver, X silver text dot append value. Okay, and then we can pass this here, text equals X silver text. All right, so I think this looks good. Let's try again. Okay, so this looks pretty good. So we have two different lines for gold and silver, and we now see that the legend appears on the right-hand side. So let's go back and simplify this code a bit. So we're basically doing this twice. So we can simplify this by declaring this up here. We only need to loop through X once, and then we'll call this silver value, rather gold value. And then we'll copy this up here. We'll call this silver value, and then we can append it to the correct lists. So gold value, silver value, and then append it to X gold and X silver. Okay, and then we can get rid of this. Let's run it one more time. Value is not defined, line number 13. Okay, so gold value, and then silver value. All right, one more time. Okay, looks good. So we have our two lines. We have the line for gold represented by blue, and we have the line for silver represented with this red line, and our data points are all showing up. So one thing I want to change is the color here. It would be nice if we could represent the gold line with a golden color, and then silver with a silverish color, like a gray color. So let's see if we can change that. And I'm going to close out all these extra tabs here. So I'm just going to close tabs to the right. And let's go into the documentation. And I want to look for a argument called line. There we go. So the argument line accepts a dict type, and it can contain these values. So color sets the line color. So let's try this. Going back to the code, for gold, I want to provide line equals a dictionary with a key called color. And let's provide a color. Now I'm going to go and look up a HTML color chart. And we'll just pick some random website here. And I want to pick a color that kind of represents gold. All right, that looks good enough. Come back here and we'll provide this as the color. And why don't we try it out? Okay, so we have So we have kind of like a golden color for the gold chart, or the gold line. Let's do something similar for the silver line. So going back here, going to copy this, paste it for silver, and I'm gonna pick a different color. So for silver, let's pick something that looks a bit like that, maybe. Okay, copy, paste, and run again. Okay, so we have a gold line and we have a silver line, but I think that these lines are a little too thin, so we can increase the width of these lines by controlling the width. So if we look at the documentation, there's a line argument which then accepts a dictionary with the width key, and the default is set to 2 pixels, but we can change that to, let's set it to 4 to double the width of the line. So this value, this setting here, sets the line width in pixels. All right, so going back to the code, I'm going to try to double the width of the line. So we'll add another argument here. We'll call it width and set that to 4. So let's save this and try to run it again. All right, so you can see that the gold line is quite a bit thicker and it's much easier to see. So I'm going to do the same for silver. I'll copy this and do the same thing for silver. And run it one more time. Okay, so let's compare this with the previous chart where the lines are kind of thin, and then once we doubled the width of the line, you can see how they're much easier to see visually. All right, so now that we have this, the other thing that I wanted to do is I wanted to add a title, and I want to add some labels here for X and Y. So let's look at the documentation. And okay, so we can use the update layout method to essentially do that. So I'm going to copy this, go back to the code, and let's add this here. So I'm going to do figure.update layout will provide a title. So I'm going to change this to the change in gold silver prices. And the x-axis title is going to be month. Okay, let's just change that to date. And for the y-axis title, we'll change it to USD. All right, let's save and run it. As you can see, the title's been added, and then we also have a y-axis label and a x-axis label. So this is looking pretty good. The final thing I want to do is I want to export this as an image file. So let's look at how we might do that. So back to the documentation, I'm just going to search for export. And the first link that comes up is static image export. If I click that, it tells me that we need to install a dependency. So let's install it. So Kaleido is the dependency we need to install. Let's do that now. Pip install Kaleido. Now that we've installed it, I'm going to update the requirements.txt file and commit that. So we will do pip freeze, redirect it to requirements.txt, do a git diff, and I'm going to add that. Requirements.txt. All right, so let's look at how to use Kaleido to actually export it. Okay, we already have a figure, so we don't need this part. To write the image file, let's create an output directory. Okay, so that sounds like a good plan. I'm going to copy this, and what we're going to do is we're going to import OS, and if the images folder doesn't exist in the current directory, we're going to create it. but I'm going to move this OS import to the top and then scroll back down. So let's create the image. So we create the directory, and once that's done, we can then export it to an image file. So Plotly can output figures to several raster image formats, including PNG, so let's just use that. So I'm going to call this gold silver chart.png, and let's try to run this. So Python graph.py. Okay. Now if we look at the Bullion tracker folder, we can see there's a new folder called images, and inside we have a gold silver chart.png file. If we open this up, we get this nice little image representing the data. So there's the gold line, silver line, X and Y axis, labels, and legend. So this is a nice little image file. I'm going to close this out, and going back to the source code, we now have the general logic to generate the line graph and then also export it. So let's now reorganize the code and refactor it a bit. We'll create a Python class, and then we'll create methods to kind of tidy this up a bit and provide a nice little API for the main application to call. My apologies for the break in continuity. I had to take care of some things, but let's continue where we left off. We said that instead of using this fake/test data, we want to grab some real data from the database and use it to generate the charts. So to do that, I'm going to open up my tracker.py file, and if you recall, we had created this class where it would initialize a database, and for each of the metals, which is gold and silver, it would create the metal, it would then get the price, and then it would create the price object and print out this message. So it would essentially initialize a database and add the prices into the database. So I'm going to run this now. So if I run tracker.py, it initializes database, and then it creates these two data points for the prices. So we have a price for gold at $1,840.13, and the price of silver is $23.94. And if we look at our directory contents, we can see there's a prices.db file. Now I want to get the metals from the database. So to do that, I'm going to open up the database.py file. And this is the file where in the second video we had created the metal and price tables. And then we created a database class which provides some helper methods. So it creates, one helper method is to create the metal, another one is to create the price, and we have methods to get the metals and get prices. So the first thing I want to do is I want to get all the metals from the database. To do that, I'm going to go back to my graph.py file, scroll to the top, I'm going to import the database class. So I'm going to say from database import database, and then scroll down to the bottom. I'm going to comment this out for now, block comment, and I'm going to initialize database, and the name of the database is prices.db, and we'll say metals equals d.getMetals, and let's print out metals. So I'm going to clear the screen, Python graph.py, and we can see there are more than 2 metals here. There's 1, 2, 3, and 4 objects, so there should only be 2. If we look at the tracker.py file, this is responsible for creating the database and essentially creating the metal objects. we can look at the logic here. So for metal and metals, we create the metal object, and then we get the price. We then create the price object, and we print that out. So there's a bug here somewhere. Going back to graph.py, let's actually print out the name of the metals. So I'm going to say for metal and metals, print out metal name is metal.name, and the ID is metal.id. Now these are referencing, if we go back to the database.py file, from the metal table, it's referencing these two columns, so the name and the ID columns. That's what's being referenced here. So I want to print this out. And so we get metal name gold, that's expected. And then we have metal name 1, which is not expected. Metal name silver, which is expected. Metal name 3, that's not expected. So there's a bug here somewhere that's creating these metals that it shouldn't. So let's take a look here. So for each metal, the first thing we do is we create the metal, we get the metal object back, then we get the price. Okay. Then we create the price object. We pass in the metal object.id. So if you look at the database.py file and look at the database class, so first thing we do is we create the metal. So back to the tracker.py file, that's where we're creating the metal. So create metal, we pass in the name of the metal. That gets passed in. We check to see if a metal with that name exists. If it does, we return the object. Otherwise, we create an object and return it. Okay. So then the next line is to get the price of the metal. Okay, so that's not related to the metal directly. And then we create the price object. So when we create the price object, we pass in the price, created at, and the metal. So for the metal, we're passing in metal object.id. Okay, back to database. So this is for create price. It accepts price created at and metal. So this is the metal ID, and we are checking if the metal is the metal ID. So this is, I believe this is where the bug is. Also here. So when we create the metal, we're passing in is the name of the metal. So XAU or XAG. One of those two strings is what we should be passing in, but instead we're actually passing in the ID because that's what's being passed in to the create price method. Right? So let's fix that. So what this should be is metal. Right? And I don't think we need metal object because it's not being used anywhere. And anyway, in the create price method, it checks to see if the metal exists. If not, it creates it. Right? So create price method already calls create metal. So if we go back, so the create price method calls create metal if it doesn't exist. So there's no need for us to attempt to create it. So let's delete this line. And then we fix this to, instead of passing in the metal ID, we're just passing in the metal name. Okay, so I'm going to clear, and I'm going to delete the database, so prices.db, and let's do Python tracker.py file. Okay, now let's do Python graph.py, Python graph.py. Okay, so that looks better. We only have two metals in there now, so XAU and XAG. Let's try to run tracker.py again, and then run graph.py again. Yeah, so we still only have two metals, so that looks better. I am going to quickly commit this fix, so git status. I'm going to do git diff, what was it we fixed? Tracker.py. Yeah, so I'm going to fix that. So with that, what I want to do now is I want to also print out the prices. So going back to graph.py, so we printed out the metals. Now I want to print out the prices. I'm going to say prices equals d.get prices. And for price in prices, I want to print out the price. So for the price table, we have the price column, created at column, and the metal ID. So let's print all three out. So we can say price is price.price, and created was price.created at, and metal was price.metal, I think. Okay, let's try. Okay, so we have the price, we have the created date, and we have the metal. Let's print this out as one line. So I'm going to say price string is, so we'll say pass in the date. So I'm going to say price dot created at, followed by we want the metal. Let's put the metal in parentheses. So this is going to be price.metal.name, and then followed by the actual price. So for the price, we just want price.price. Okay. Then we want to print that out. And let's clear the screen, run again. Okay, so what happened here? I forgot to put in F because these are F strings. Okay. Clear, try again. Okay, so that looks good. That looks much better. So we have the date, we have the metal, and we have the price of gold, price of silver, and for these are for two different runs. So one was at 2:48 p.m. and the next one was at 2:48 p.m. 22 seconds. Okay, so this looks good. Now, of course, our chart's not going to be very interesting because these are the same data points, right? So it's going to be a flat line. But let's add in a couple more data points here. So I'm going to do Python tracker.py. So I'm going to do Python tracker.py. Run it one more time. And if I clear the screen and run graph.py, we should have 4 data points now, or 8 total. So we have 4 sets, 1, 2, 3, and 4. And so the prices didn't really change at all. And but we have real data as opposed to fake data. So now that we have real data, what I want to do is I want to generate the chart. But remember, we need to pass in these X and Y values. So for X, we need to create a list of dates. So this is the X-axis. So instead of January, February, March, April, we need to provide in these dates. But let's format this a bit better. So I don't want the time. All I want is, let's say, the month and day. And yeah, might as well pass in month, day, hour, and minute. So let's pass month, day, hour, and minute. Might as well pass in second because we don't really have a whole lot of granularity here. Okay, so we'll pass that in. And we'll just leave this part out. So to format date time objects, because that's what this is a date time object, let's look at the Python date time documentation. So I'm going to do Python date time. And I want to look at the string format time. So that's strf time, string format time. And I want to get the let's say, now we said that we wanted, what did we want? We wanted year, month, day, hour, minute, second, right? So we want year, so that's this. So that's %y, that's a symbol. Month is going to be %b, and then day is %d. Okay, so let's do that. So let me split this up. So this is going to be price.created@, dot string format the time, and I want to say %year. Let me just run this real quick just to make sure the syntax is correct. Okay, closing parentheses doesn't match. Yep, so let's Okay, so we have the year 2020, and then we also want the month, so that's %b we said, and %d for day. Okay, it's 2020, December 13th. All right. Now we also want hour, minute, and second. So hour, let's say 24-hour clock. That's %h, minute, %m, second, %s. So these are all capital. All right, so we can say %h, %m, %s. Let's try again. Okay, so that looks much better. Year, month, day, hour, minute, second, gold, silver. And then we have the price points. So we now have data for the x-axis, so let's populate that. So we can say x equals empty list for now, y gold, empty list, y silver, empty list, and then we can say for price and prices, well, first of all, for x, we need to populate the dates. So we can say the date string is equal to that. And for this, we can just pass in date string. Okay. So let's run this again. Okay, looks good. So I'm going to append this to x.append date string. Okay, so that'll populate our x-axis. Now we need to add in the data points for gold and data points for silver. So then what I'm going to do is for y gold, I'm going to append the price dot price, but I won't want to do this for gold. So I'm going to say if price.metal.name is equal to XAU, then I want to append it to gold. Else, because we only have 2 metals for now, I'm going to append this to y silver dot append price.price. Okay, and we can still print that out if we want, but I also want to print out, once we're done with this loop, I want to print out x, and I also want to print out y gold and y silver. Okay, let's run that. Okay, so for the x-axis we have this date, this date, this date. So 144804, 144805, 22, 23. Okay, so the x looks okay. For Y gold, we have decimal. So instead of decimal, I want to pass in, I think it's fine to pass in decimal, but I am concerned about the x-axis has basically double the number of data points, and then gold and silver only have 4 each. And so the reason for this is, if we look at the tracker.py file, when I create the price object, get price, okay, and then we create the price object. So basically we're creating different, we're creating the, passing in a created at date time that's unique per instance. So instead, what I want to do, because I want every price, every gold, silver, whatever the metals that we are querying at that moment to have the same date, I want to make this more consistent. So I'm going to say created at is datetime.now. And in fact, I'm going to move this outside of the loop. And then we can say created at is created at. Okay, so that should give us more consistent values for x. So I'm going to clear the screen, delete prices.db. I'm going to run tracker.py file. There's a syntax error. So line 43. Okay, so db, so this should have been back here. Okay, let's run again. All right, let me run it a couple more times. Okay, now if I run graph.py, we have, okay, 0808. Okay, so the date times are essentially the same. So then what I want to do in graph.py is for the x, I'm just going to do a check here. I'm going to say if not date string in x.append date string. Okay, let's run it again. All right, so that's given us exactly 3 data points for the x-axis, and 3 data points for gold, and 3 data points for silver. So we have x, y, and silver data points. Now we can just basically call the graph and render it. So I'm going to copy this, go to the bottom, paste that there, uncomment, and I'm not going to export it for now. I just want to see what it looks like. So let's clear the screen, run graph.py. And like I said, the graph isn't very interesting because it's a straight line, but we do get the trend line for gold and silver. And we can see the data points here. So for 2020 December 13th at 3:02 p.m. and 6 seconds, we have a price point, and we have a price for a couple seconds after that, a couple seconds after that. And we can see the values too. So this is $1,840.13, and for silver, it's $23.94. Now let's try to export this. I'm going to say export equals true. And if I open up my Bullion tracker folder, I'm going to go into images, and let's delete this and rerun it. And now if we look at the command, it just exited, and we now have an image file. If we open this up, we have our image file. But notice how the price points are all scrunched in, so it's kind of hard to read. It's less of an issue here because the image hasn't been resized, but we do need to think about that. So instead of printing out this many decimal places. We only really want 2 decimal places. And then we can even reformat the date to be, to be a little more concise. So what I want to do is I want to change the title to reflect the date. So I'm going to say like 2020, December 2020, or even the full date. So 13th December 2020, and then for this we can just have the time, and then we can reduce the amount by leaving in only 2 decimal places. So let's make that change. So for the date string, we have, okay, so first of all, going back to the graph.py class, or the graph class, how do we generate the title? So the title is kind of hard-coded in, right? So what I want to do here is I want to pass in the title date, right? So we'll make this an argument, so title date, and then that can be added here. So I'm going to say title is title date. So title is title date, which is passed in. So now we need to provide this to the render method. So I'm going to say title is going to be so the current month. So what's today? Datetime.now, and then I want to string format time, %year, that's the year, and then %month for the month, right? Let's go back to the date and time documentation. So %y is the year, and then the month is %b. All right, so I can say %b, so like January and then 2020. Okay, so we pass that into the render method, and if I run the code again, oops, we need to import datetime. Let's go back to the top. From datetime, import datetime. Okay, so we have change in gold silver prices for December 2020. So now we can get rid of December 2020 here. Oh yeah, we said that we want to also include the day. So let's go back. And so this is the day, so %d. Okay, let's rerun it. So 13 December 2020, that means we can get rid of this. So get rid of this. And we have hour, minute, second. Now let's run this again. All right, so this is now reduced because we now have the date up here and we don't show the year, month, day for each data point. So compare this to the previous report or the previous graph. So this is a bit more concise. Now we said that we want to reduce this to 2 decimal places. So what I want to then do is going back here for gold and silver prices, I want to format this to be only 2 decimal places. So let's look at the Python decimal format. So we can format it using this method, or this syntax rather. So for format float to 2 decimal places, we just use :.2f. Let's go back here, and I'm going to say I want to append. Hang on, let me just check. Okay, but that renders it a string instead of a float. All right, so let's just work with strings for now, but eventually I think we need to update our graph class to actually handle this. So I'm sure that the Plotly has some internal method or some internal way to process decimal objects and to only display 2 decimal places. So we shouldn't really be passing in strings, but let's just do that for now. Price.price. Okay, so I'm going to just basically say .2f. Okay, I think we need to do .format. Let me double check. Yep, so :2f.format and then the number. Okay, :2f format, then the number, and we'll follow the same thing for here. Now, this is essentially duplicating the same exact string, so let's create a new variable. I'm going to say price string is this, and then we can just pass that in. Okay. And I think we can get rid of this for now, as well as these lines. All right, so let's try again. Okay, so that looks a whole lot better. So we have a date, and then we have the numbers, 23.94, 1840.13. So this looks a whole lot better. Let's check the exported image. Yeah, so this is a whole lot more readable too, because it's not a lot of overlapping text. All right, so let's now go back to our code, check to see what we need to clean up. So we can get rid of this, get rid of these print statements. We don't need this anymore. We can move this to the top. Delete the extra blank line. All right, so that's it for graph.py. I don't think we changed anything for database.py. And for tracker.py, we made that fix and committed it, so let's clear, git status. So let's check, do a git diff on graph.py. So we added in datetime, and then we imported database. We updated the render method. We refactored the title variable, and instead of passing in this dummy data, we now generate actual data from the database. And we created the logic to essentially populate the XY lists. And then we refactored the render method, provided the title date. Okay, so let's stage the file. And we also changed the tracker.py file. So let's commit that too. And we have an images folder that we don't really want to track, so I'm going to open up the gitignore. I'm going to add that to the gitignore. I'm going to say images, save. If I do a git status, Okay, let's push this. All right, so looking back at the Boolean tracker plan, so we said that for this video, we were going to use the Plotly Python library to create the line chart and to also export it as an image file, which we've done. So looking at the images folder, we now have an image file with our graph. So if we want, you can then email this to yourself or use it as data for your websites. And unfortunately, we don't really have interesting data points here. It's just a straight line for silver, straight line for gold. But what we can do is in the next video, in the final video, we're going to look at how to create a schedule for checking the prices. We'll use Python Celery to do that. And with this, I can then leave the schedule running. So I'll create a schedule to basically run the tracker.py file maybe like every hour for a couple of days, and then that'll give us enough data to then generate some really interesting charts, and hopefully we'll see some fluctuations in the price over some period of time. So that's it for this video. If you found this interesting, please check out the next video. It's going to be all about using Python Celery to create a schedule to check the prices automatically. Thank you.